Hey folks, welcome to this week's episode of EuclideanAI. This week we are going to talk about spec-driven development. In the traditional Agile Scrum world, if someone creates a Jira ticket or functional requirements, you don't write this into your codebase. Normally, when development starts, commits are linked to the Jira tickets. This is as far as the linkage between a spec and the codebase goes. With a spec-driven development, you'll actually have the specification tightly coupled with the product requirements and the actual codebase. In this episode, I will show you what I mean by this and use the open source framework called Speckit, which has received 41,000 stars on GitHub recently. If I compare the vibe coding with the spec-driven development, although they are both using natural language to instruct AI to produce software code, the latter provides a more structured approach to reduce things like hallucination and keep AI regulated within the specification. Again, you don't need to be a professional developer to be able to use this tool. You can be a product manager or anyone who is interested in solving the problems. Now, to kick off, there are a few initial steps. The first step is to get Python and the Python package manager on your computer. The easiest way to do this is by using a tool called UV. Let's go to UV's website and follow the instructions to install it on your machine. The second step is to install the Python runtime. Click the left-hand tab to see instructions for installing a specific Python version. I recommend Python 3.13. After these two steps, come back to the Speckit repository and copy and paste the installed command into your terminal. It will start installing Speckit, and after a few seconds, you should be able to run it for your project. The last thing we need, if you haven't got an IDE, stands for Integrated Development Environment. VS Code is the one I use, but feel free to use anything else like Cursor, PyCharm, or whatever works for you. Now, I know it sounds a bit daunting for someone who's new to coding, but by now we have got all the tools we need. Let's talk about what we are going to build today. We are going to build a Trello clone. For those of you who haven't used a Trello before, it's a lightweight project management tool where you have a user interface to create the tasks as cards, and then you can drag those tasks along on the UI between different stages that you defined for your project. The core features we want to build are creating tasks, displaying them as draggable cards, and moving cards between columns to represent the different workflow stages. It sounds straightforward, but this is a great example to show how Speckit can help us structure the requirements and guide the development process. We will see how Speckit let us define these features in a specification and then use that spec to drive the code generation and implementation. Let's get started by opening our terminal. Navigate to the directory where you normally keep your coding projects. Once you are in the projects folder, you can just use the Speckit to initialize a new project. Run the following command: specified init Trello-clone. Once the project is initialized, it's time to open your IDE. For example, if you are using VS Code like myself, you can navigate into your new project directory and launch the VS Code. The first step within the Speckit is to use the magic command /specify.constitution. This tells the coding agent to generate a constitution document. By constitution, we mean a high-level requirement for code quality, testing standards, and keeping the user experience consistent. These are just broad requirements. We don't need to get into too much details yet. Because it's open source, Speckit supports most mainstream coding agent that's available, whether it's through your IDE or CLI. I picked the Claude Sonnet 4.5 with GitHub Copilot. AI agent will read the constitution template and update it accordingly. And now let's have a look at the constitution doc. once it's finished. If you go to .specified folder and then open memory subfolder, you will see the updated constitution document. Let's review what it says. The first section covers code quality standards, stating the code must maintain professional standards to ensure maintainability and readability. There are also high-level requirements, such as functions and components having single clear responsibilities and eliminating the code duplication. Type safety is emphasized, which is important for TypeScript. The document also outlines the testing standards requiring the coding agent to use the test-driven development, meaning it writes the test code before the actual implementation. It mandates unit tests and integration tests. If you enjoy the content we shared on YouTube, please give us a like and hit the subscribe button. You can also visit our EuclideanAI website for more detailed content. You will find the latest videos, blog posts, and courses. Many of these resources are free, including online courses and GitHub repositories to help you get hands-on experience and follow step-by-step tutorials. If you have questions, best way is to join our Discord channel with the invitation link down below to interact with the community. Once we're happy with the constitution, let's move on to produce the actual specification. To do this, we use another / command, Speckit specify. Here, we provide more specific requirements and describe the product we want to build. Let's say we want to build a lightweight project management tool inspired by Trello. The tool should have a UI with tasks displayed as draggable cards. Users should be able to add, modify, and remove tasks. The cards can be dragged across different columns, which represent different stages of the project. After a few minutes, the coding agent saves the specification in specs folder as a spec.md file, updated based on our prompt. Inside this file, you will see our original input, followed by generated user scenarios and testing requirements. The document lists the functional requirements, assumptions, key entities, and measurable outcomes as the success criteria. This results in a detailed specification for our MVP. Up to this point, we haven't specified anything technical. The next step is to define the technical requirements. To do this, we use another / command, Speckit.plan, where we provide our technical and architectural requirements. For example, we want the project to use Next.js 15. Since Next.js 16 is less stable and the coding agent may not have enough training data for it yet, the app should be full stack using Next.js app router and API routes. For the MVP, we assume there's no authentication or authorization, so we focus on the core functional features and user interactions. We also instruct the coding agent to use SQLite for local development. Prisma is the ORM, Tailwind CSS for styling, Shadcn UI as the UI components library, and Lucy React for icons. The coding agent takes these requirements and generates a plan.md file under the same folder as this spec. This plan file serves as a technical specification outlining the architectural and the solution details, including the folder structure and the tech stack. The AI agent used this plan to generate detailed implementation tasks. Now, let's move on to task generation. For this, we use the command /Speckit tasks. You don't need to provide much prompt this time, just run this command. The coding agent will read through plan.md and generate a new file under specs folder called tasks.md. This file will outline implementation phases, purposes, and a detailed list of tasks with checkboxes. To recap, we've used 4 main commands so far. Constitution, which is used to set up the high-level quality standards and best practices. Specify to generate the specification. Plan to generate the solution document tied to the spec. Tasks to generate the detailed task list. Before we run the last command, let's make an initial git commit to save all documentation. After this, we move on to the most exciting part, getting the project built by running the last speckit command. Speckit.increment. When you run the implementation command, the coding agent will strictly follow the tasks.md file and begin implementing the project. It will start by setting up the Next.js 15 project, then quickly work through the task list. Once it's completed with phase 1, we can run it with npm run dev, and we can see it has got Next.js up and running. The next task is to create the task cards in the column that represent the different stages of the project. The coding agent was able to complete this step, but the cards aren't draggable yet. The following step is to make them draggable. The agent followed the task list closely when it encountered a few bugs. I simply copy and paste the error messages from the browser back to the agent, and it was able to fix them without me needing to write any code or intervene directly. The next step is to finish the function for creating a task, which involves making API calls to store tasks in our local SQLite database. After that, I polished the UI by adding a Lake Wanaka background image to the Trello clone, which turned out quite nicely. At this point, the project is almost complete. It took about an hour to build a Trello clone with a spec kit that has proper documentation, specifications, solution design, and detailed task plans. There were some bugs along the way. Overall, it was a good experience. Some documentations could be more concise, in my opinion, to reduce token consumption. But the outputs are very useful. The final documents include a clear API contract, a data model or schema for Prisma, API endpoints under Next.js app router, and a SQLite file with all the tables for the data storage.